So let us discuss about Einstein's explanation of photoelectric effect. So Einstein have explained this photoelectric effect in terms of Max Planck's theory. So according to Max Planck's theory, light consists of tiny packets of energy called quanta or photon. Correct? So let us discuss about it. So answer, how to write the answer is, so Einstein explained. So Einstein explained photoelectric effect on the basis of Max Planck's quantum theory. According to this theory, okay, light consists of what? Okay, I will write down here. Light consists of tiny packets of energy called quanta or photon. Correct? Quanta or photon. Right? Energy of each photon given by what? E is equal to h nu. This is what the first thing you have to explain. While Einstein explanation on photoelectric effect, you have to write this first. Okay, so where h is the Planck's constant, nu is what? Yes, of course, frequency of light. Yeah, frequency of light. So once you finish this one, so next, when photon of energy is equal to h nu falls on metal surface, falls on metal surface, however energy is there, right, for photon. The energy of photon is, this is what Einstein says, utilized in two ways. Is utilized in two ways. Okay. So what are those two ways? Okay, let us see. I will write down that here itself. Okay. Here I will try to write. So this is the body of the answer initially. So Einstein's explanation on photoelectric effect we are discussing right now, and of course Einstein has studied about the Max Planck's theory and he has given his explanation on basis of Max Planck's theory. According to Max Planck's theory, light consists of tiny packets of energy, like that you have to say, and the energy of this one is given by, of course, E is equal to h nu, and its name is like quanta or photon. Next, he starts explaining who Einstein. When a photon of energy is equal to h nu falls on metal surface, the energy of the photon is utilized in two ways. Okay, the energy of the I think you can see that energy of photon is utilized in two ways. You can see there. So, what are those utilization of energy of photon by the metal surface? In two ways. Let us see. Two ways. In that first one, a part of energy is utilized in liberating electron from metal surface. Okay, so whatever the photon of energy is h nu, which is actually incident on the metal surface, is there, right? So what he explained is the energy which is given by the photon is actually utilized in two different ways. First one is, look at here, a part of energy is utilized in liberating the electron from the metal surface. So this energy is equivalent to what? Halbach and Lennard's experiment. There it is something called the minimum energy required to remove the or make the electron to jump out or come out of or get ejected from the metal surface is called which one? Work function, correct? Yes, here also it is same. From the metal surface, which is, okay, I think space is sufficient, which is equal to work function. Okay. Work function phi naught. Yes. Second one, that means what is the remaining? The remaining part of energy is imparting maximum kinetic energy to the emitted photoelectrons. Okay. The remaining part of energy utilized to impart, it means give maximum kinetic energy, impart maximum kinetic energy to the emitted photoelectron. Kinetic energy to the emitted photoelectron. Hope you can see this. You are able to read that. So energy is utilized in two different ways, students. Look at there. I have written there 2 points. Okay, take down neatly. So what is given there? A part of energy is utilized in liberating the electrons from the metal surface, which is equal to the work function phi naught. The remaining part of energy utilized to impart maximum kinetic energy to the emitted photoelectron. Okay, fine. Hope you understood this. So take down neatly. Fine then. So these are the way of initially writing the Einstein explanation on photoelectric effect. Fine then. So, as he said, two ways. What happens? Energy will be utilized. Which energy? Of course, E is equal to h nu itself utilized, right? So let me write that. We'll erase this first. So Einstein's explanation on this we are discussing, right? So once you finish the depending on the basis of Max Planck's quantum theory, then thereafter equation we have written, and energy is utilized in two different ways. So first one is actually to liberate the electrons from the metal surface, which is equivalent to the work function. Second one is to impart maximum kinetic energy to the photoelectrons. So what is the energy which is given by the photon? E is equal to the energy of photon is utilized in two different ways, correct? One is as the work function, one more as what? Maximum kinetic energy, Kmax. Correct. This is what Einstein has given the equation, and for this equation Nobel Prize was there for him. He was awarded with Nobel Prize. So what is the energy actually given by the photon? H nu is equal to phi naught plus K maximum. Okay. So how we can write this one now? So K max, that means half m max square equal to h nu minus what is phi naught? Work function. Work function is also equal to what? So energy required to come out, right? That is h nu naught. Am I right? So half V max square is equal to h into nu minus nu naught. This equation we get. So I will write this one. Okay, if you write like this, no problem. I will try to write, instead of writing in the explained form, I will just write in basic form. Okay, what is that? K max equal to minus phi naught. Let it be like this itself. Okay, so that I can frame two different equations, because earlier it looks like almost same. That is why. Now two equations are there. Okay, both are one and the same. Right hand side of the equation can see there. So what he explains, so he took the Max Planck's concept and he explained the energy will be utilized in two different ways. One is for liberating the electron from the metal surface, which is equivalent to the work function of Halbach-Leonard's experiment. Then one more is like remaining is actually utilized to impart maximum kinetic energy. That means to make the electrons to move. That is what he said or explained. So thereafter he has given the equation, he has explained it. Now explanation based on this. Which one? Based on the equation 1 and 2. What are the explanation? Let us see. The basic process involved in the photoelectric effect is absorption of photon of light by electron. Okay. The basic, what he explains is, Einstein, the basic process in photoelectric effect is absorption of photon. See, suppose the same thing explained by Halberg means they just treat it as a wave. When light of suitable frequency falls, like that. They didn't explain much about this, correct? But Einstein says it's nothing but just absorption of photon by whom? Electrons. Photon by electrons on metal surface. See how nicely and clearly he explained it. That's why he is a Nobel laureate, correct? Therefore, this process is instantaneous. Okay. And it is instantaneous. Okay. See, there also it was like it's an instantaneous process. That's what it is being said. Here also. Einstein also has the same thing. That means he said the same thing. Like what? It's an instantaneous process. But what he said, he didn't say that just light of suitable radiations will come, suitable frequency will fall. No, he has explained like what? Is something like, it's very basic. What? Give and take. Electrons will absorb photon from light, utilize the energy, comes out. How it utilizes energy? In two different ways. That is what already in the equation it is been discussed. So first point is over, and he said at the end of the sentence, Einstein explained that it's instantaneous. The process is instantaneous, he said. Okay. Second one, what is that? In equation 2, okay, in equation 2, if incident frequency is less than threshold frequency, okay, in equation 2, if incident frequency is less than threshold frequency, what happens? If this is less than this right side of the equation becomes negative and kinetic energy becomes negative, whether it is possible, whether kinetic energy can become negative, of course, not possible, correct? Look at the equation. Okay. So, if less than threshold frequency, that is nu less than nu naught, then maximum kinetic energy becomes negative, which is not possible. Okay, so there is some fixed frequency below which suppose any other frequency comes means negative kinetic energy, not possible. Therefore, what it says, therefore there exists a threshold frequency. See how he proved it nicely? Frequency. Okay, there exists a threshold frequency. There exists. So 3 points. Have a look neatly. Okay. After the equation, 3 points. Sorry, 2 points I have written right now. Hope it's visible for you. Take it down properly. Okay. So, if incident frequency is less than threshold frequency, then maximum kinetic energy becomes negative, which is not possible.